All right, Aubrey and whoever else I'm recording, Kellen and Colton and all the other people. Here is the homework assignment. 731, 2 through 28 evens. Make sure you get them written down. Ready, set. Geometric probability. This is 2 through 28 evens. Geometric probability. This is probability involving geometry. All right. So first things first, they give you something fairly easy, but still maybe a little bit complicated. So let's take a look at this. Let's just dive right into example 1. Here we go. I want to pick a point that's going to live on this line. How long is that line? 25, right? 25 units long. And I want to pick a point that's going to live on that line. I want to know the probability that it lives between P and S. So, wait. Lives on RS, excuse me. I want to know the chances that it lives here as opposed to anywhere else on the line.
10 out of 25.
Right? 10 units is how many units it could live on out of 25. And if we reduce, divide by 5, 2/5. There you go. Or 0.4 or 40% or whatever. 2/5 is fine though, right? Got it? Not too bad, right? Okay, now this is where it gets a little bit tougher. Hold on, Jacob. Go to example 2 on the next page. Okay? There's lots of words going on here. Don't get discouraged, okay? A website, listen. A website that hosts an imaginary sharing gallery updates its front page, listen, for new content every 6 minutes. Okay? So I have a number line that's going from 0 to 6. That's what they've done right here, right? It's updating every 6 minutes. So I have it's every 6 minutes it's starting over every 6 minutes. So I have a number line that's lasting 6 units long, right? Okay. Assuming that you open the gallery at random, what is the probability that you have to wait 5 or more minutes? That's just saying what's the chances that you live here as opposed to all of the other ones, right? How long is this? Versus 6. So 1/6. You see how that works? Okay. They don't have the number line drawn for you always. This one they did, obviously, because they're solving the problem with you. But that's how that works. Let's do the check real quick. Do we have a check on that one? No, we don't.
That's the one for the
That's the one for the other one. Okay, but if they don't give you that information, there it is. Draw a number line and then look at your sections. Got it?
Yep, go.
All right, next, probability with area. Put this off to the side over here. Everybody write this down. Everybody write this down. Everybody write this down. Area. Bottom left corner. Probability with area. There are 4 things that you are finding the area of that you should know how to find the area of. You should have these memorized. You betcha. Circle. Square and rectangle are the same, basically. So I'm going to say square / rectangle and triangle, right? Write these down. These you should have memorized. Okay? Area of a circle is how much?
Pi times radius squared.
Pi r squared. Awesome. Put that down.
Oh, it is?
Yeah, you're right. How do you find the area of a square or a rectangle? Length times width or base times height, however you want to say it, right? Okay. So if it's a square, then the length and the base and the height will be the same. If it's a rectangle, they will not be the same. Let me make him rectangular. Ugh. Let's do that again. Whoop. Let's say this is 5 and this is 3. What's the area? 15. Let's say I have a circle where my radius is, we'll go radius is 10. What's the radius squared?
14.
Yeah, what's the radius squared? 100. What's 100 times pi? Move the decimal 2 places. 314.2, right? We'll say 314.2. Got it? Okay. Now, a triangle. Let's talk about this triangle. Let's say this is 5 and this is 3, right?
Half times base times height.
Yeah. 1/2 the base times the height, right? This is half of a rectangle. Got it? So 7.5 for this one, right? 7.5. Okay. Those you should know. You should have those memorized. If you don't, memorize them, okay? That's what we're going to be doing with probability with area here in just a second. All right, let's go down to example 3. Ready? Go to example 3. It's the top of the next page, whatever next page it is. Okay, example 3. Shh, you guys got to listen. Here we go. Haruku Games is designed is designing a new lawn game where each player will attempt to hit a circular target by tossing a beanbag into a larger circular board. What is the probability that the toss will land on the target? The target is the red one. Now, we have to assume that when I toss it, it will in fact land in that brown area, but what's the chance it lands in the red area versus the brown area, right? So what we're doing is we're doing the area of the red over the total area, and the total area is the area of the brown, right? Yeah? Do we see how that works? How do I find the area of that red circle? Okay, but 4 is the diameter, not the radius. So pi r squared, and the radius is 2, yeah? Okay, hold on, no, just wait. Listen. Okay, don't multiply that together. I'll show you what happens here in a second, right? Versus the other one, the other one is in feet. So let's go 24 inches, so be careful, okay? Pi times, what's the radius? The radius is 12, pi times 12 squared, all right. 2 squared is 4, that's 4 pi over. 12 squared is 144 pi. Now what?
Divide by 5.
I'm going to just drop the pi's off. They reduce. And 4 and 14, that will divide by 4. Yeah, you're right. 1 and
Probably something.
36. 1 and 36. You can divide that in your head. 144 divided by 4, can you do that in your head? No. You should be able to.
24, 6, and then 120.
Yeah.
Is it okay if we put pi over 36 in our homework for that one question?
I don't do it that way. I don't know. 1 over 36. That's the probability. Okay, yes, Jacob. What's your question?
Well, we need to go back to the first one now.
Why?
Because that's when I asked my question.
Okay, go back to the. What, Jacob?
What if it lands exactly on one of the points?
Then it's between it.
Then does it count as being
They're calling that inclusive. So from R to S, if it lands on R, that's still counted as RS.
Well, then does it count as QR then too? So is it
Yes.
multiple?
Yes.
Yeah,
Okay.
yeah. Weird.
Okay.
Yeah. Technically, R is in this segment and in that one. Yeah.
Factor that in.
No. Yeah. Don't make it that hard. I get what you're saying. Don't listen to Jacob. He's trying to make it hard. Okay, go to example 4. Go to example 4. You guys have this spinner up in the top left corner? Yes.
No.
This is in degrees. Shh. You guys gotta listen. I'm tired of shouting. This is in degrees. How many degrees is a circle? 360 degrees. Use the spinner to find the probability of landing in each section. All right. I want to know A, the probability that the pointer lands on purple.
30 degrees.
Purple is 30 over 360. And if you divide that, that's 8.3%. Yeah? Okay. B, the pointer lands on green. 125 over 360, which is, I don't know. Somebody give that to me.
Something.
125 over 360. Jordan's got it? 34 point what? 7%. Awesome. Okay. The pointer lands on, neither red nor yellow. So I don't want this section, right? What is red and yellow together? 145. That means if I subtract, what's the other ones? 215. So I want 215 over 360. Okay? While we wait, what's that called where we subtract it? It starts with a C. Nope. It starts with a C. What's it called when you subtract it? So if like we're finding like not yellow and red, what's that called? Nope.
Oh, like, is it like
Oh, you're close.
Position.
Nope.
condensation?
Nope. It starts with COMP.
What are we trying to figure out?
Comprehensive.
What's it called when you subtract it? You had it on your test today.
Subtract what? Say it.
Like yellow and not yellow. Those are called?
Ellie didn't pass.
Complimentary.
Complimentary.
Not complimentary, just the complement.
Oh.
The compliments.
I said that one.
Me too.
Okay, they complement each other because they add up to be 100. Okay, what is 215 over 360? Jordan, what do you got? What? 59.7 degrees. Or percent, not degrees, percent. You did?
Close enough.
Okay, sorry, I didn't hear you. 59.7. Okay, everything's out of 360 because 360 degrees. Got it? Yeah? Now, hold up. What happens? Real quick. Sometimes they will switch it up on you. What happens if they do this as like percent?
Well, that.
Then it's already in percent, right? Percent is out of 100. Degrees is out of 360, right? Okay, so there you go.
No. No.
Okay, last one. Yeah? Here we go. Last one. Listen. Listen for the last one, then I'm done talking. I will wait for you. Even if I have to wait till after school, that's fine.
No, thank you.
Example 5. Using probability to make decisions. Here we go. We have a friend suggested that Jayla do a tour with DeMarcus rather than Cody because DeMarcus's tour was more informative. But tours with DeMarcus depart every 45 minutes. Okay, so we have this going on. We have every 45 minutes like a number line. We could wait 0 minutes, we could wait 45 minutes. But here's the problem. I have another tour that is departing every 30 minutes. So I have like a second number line going, right? Going from 0 minutes to 30 minutes. Kind of like where it's resetting every 6 minutes, the question that we had, like the second question that we had, right? But how do I do it where there's 2 of them? I make one an x-axis and another one a y-axis. So this side is DeMarcus. DeMarcus, because it's departing every 45 minutes. Do you see where the cutoff is 45? 0 out of 45 minutes is going there, yeah? Cody is the bottom one, whatever tour that is, and that's departing every 30 minutes. Got it? Okay? So it's like making a grid right here. Okay? Now, if I do area of that grid, what's 45 by 30? What's that multiplied together? 1,350. Okay, so that has an area of 1,350, right? They say, I want to know what is the probability that she will have to wait 20 minutes or less. Okay? 20 minutes or less for either tour, right? 20 minutes or less, 20 minutes or less. That's this blocked out here, which is 400 as an area. Okay? So how do I make that a probability? 400 over 1,350. Yeah, I can cross off a 0. I can divide by 5.
8 over.
29.7%. Okay, that's the chances. So a little less than 30% of the time. A fourth of the time, I'm going to wait less than 20 minutes for either one, right?
Well, if you rounded it
Okay.
up, it'd be 30.
It's
Big,
29.6%.
What?
Sorry. Come on, Sienna. What are you
You're in
doing?
chemistry.
Yeah, 36 big.
You better not be a math teacher.
Okay, all right, we'll skip part B. But there you go. Got it? 20 minutes or less. Got it?
I was just saying.
Area over area. This is geometric probability. You should know these areas, right? They will ask you those areas. All right, 2 through 28 evens. Use your time to work. You've got a lot of time.
I don't want to.
You do. You have a lot of time. No. Just kidding. All right, get to work. Get going.